Good morning, good afternoon, and good evening to everyone. This is Andromeda group member speaking. Today we are going to be presenting our group's video lab report for PHY110 lab experiment for experiment number 4 and number 6. First, we shall start with experiment number 4, linear motion.
I will start with the objective of this experiment 4. Number 1. To investigate the relationship between force, mass, and acceleration. Number 2. To determine the acceleration of an object under a varying force. Now, let's move on to the apparatus needed for this experiment. The apparatus needed is air track rail, blower, pressure tube, gliders, flag, photo gates, masses, mass hanger, string, and pulley. So this is the procedure for the experiment for linear motion. Number 1. The linear air track set was assembled as shown in figure 4.3. Number 2. The pump was switched on and air was allowed to blow through the track for several minutes. The track was balanced by adjusting the screws on the legs of the track so that the glider remained stationary and did not glide to either end when released. Number 3. A hook was inserted at one end and a flag was placed on top of the glider. Number 4. The mass of the hanger and the mass of the glider were measured and recorded. The length of the flag was also measured. Number 5. One end of the string was attached to the hanger and the other end was attached to the glider. Number 6. Masses of 20.0 gram were placed on the hanger and 80 gram were placed on the glider. The string was passed over the pulley. Number 7. The glider was positioned exactly before the photo gate. The glider was released and the time shown on the photo gate was recorded. Note: to prevent the masses from crashing to the floor and scattering, the glider was cut by hand before the hanger reached the floor. Number 8. The procedure was repeated 2 more times to obtain the average time values. Number 9. The slotted mass of the glider was decreased by transferring a mass of 20 gram onto the hanger. Step 7 and Step 8 were repeated. And lastly, number 10. The procedure was repeated 3 more times with 20 gram from the slotted mass on the glider transferred to the hanger for each iteration.
In conclusion, this experiment investigates the relationship between force, mass, and acceleration based on Newton's second law of motion. By analyzing a system with two masses, m1 and m2, connected by a frictionless string, we can observe how varying the force, the changes in the mass m2, influences the acceleration of both masses. According to the theory, the accelerations of both masses are equal in magnitude because they are part of a single system. Using Newton's second law and eliminating the tension force from the system's equation, we can derive an equation for the system's acceleration. The experimental procedure where m1 starts at rest allows for the measurement of acceleration and provides insight into the fundamental principle of motion. This experiment helps to validate the relationship F equals to ma, confirming that acceleration is directly proportional to the net force and inversely proportional to the total mass of the system.
Experiment 6. Hooke's Law. Objective: to verify the accuracy of Hooke's Law. Now let's move on to the apparatus. Helical steel springs with supporting stand and scale. Set of slotted weights with hanger and weight balance.
The mass of the hanger was measured and recorded. The weight of the hanger was recorded and calculated as W in the table. The scale was adjusted until the pointer on the hanger is near the upper end of the scale when the hanger is unloaded, and the position was recorded as X0. The hanger was loaded with 30 grams of mass. The reading was recorded and the mass of the load was increased with suitable increment to obtain multiple data points before the lower end of the scale was reached. All the data was recorded in the table. The process was reversed by unloading the same load until it reaches the same state as procedure number 3. The reading was recorded for each load unloaded. The extension of the spring was calculated. The extension of the force acted on the spring was determined on each total loads. In conclusion, the experiment aims to verify the accuracy of Hooke's law, which states that the restoring force of a spring is directly proportional to the displacement from its equilibrium position. By observing the motion of an object suspended from a spring, it becomes evident that the force exerted by the spring balances the stretching force when the system reaches equilibrium. This validates the principle of simple harmonic motion, where the object oscillates back and forth as long as the restoring force follows Hooke's law. Through careful observation and measurement, the relationship between force and displacement can be confirmed, supporting the theoretical framework of Hooke's law in the context of oscillating bodies and elastic springs. That is all from Andromeda's group project. Thank you.